Hello everyone, today we're going to do an example question on hydrolysis of salt solution, and then we're going to calculate the pH of a salt solution. Okay, so for this question, given you have a salt with sodium fluoride, okay, and then you have the concentration of the solution, and then you have it at 25 degrees Celsius, and then we also have the value Ka for this hydrofluoric acid. Okay, and now we're trying to determine the pH. Okay, so always I would like to have everything listed out. So the given information will be the concentration of this salt solution. Okay, so it's going to be 0.22, and then it's at 25 degrees Celsius, and the Ka for HF is 3.5 times 10 to the negative 5. Okay, so then again, even just say you didn't remember hydrofluoric acid, HF is a weak acid, but now since you have a Ka value for it, it's quite small, so that should have remind you hydrofluoric acid is a weak acid. Okay, so that's your weak acid. Okay, now we're trying to find the pH of a salt solution. Okay, so we're trying to find out the pH of this solution. Let's see how we're gonna solve this. Okay, so for this salt, first of all, let's think about it. When you have this as an aqueous solution, what do we say aqueous solution? The solvent is water. Okay, so once you have this, okay, put into water. Okay, so that means I'm gonna have as AQ. Okay, so salt solution. Okay, so when you have this, what do you really have in this solution? Because it's a soluble salt. Okay, so then it's going to be 100% turned into ions. So you have sodium ion and fluoride ion. Okay, so you have these two. Okay, and then in order to find out the pH of this solution, so you really should think about, okay, these two ions, this one and this one, which one will affect my pH, right? Because you only have these two ions in your solution. Okay, so now let's look into these two. Okay, so the first one we have is sodium ion. Okay, so then you go, where does this sodium ion come from? Okay, so sodium ion is really the cation of a strong base, which is NaOH. Okay, so it's a strong base. Therefore, again, a quick reminder, you do need to know your 6 strong acids and strong bases. Okay, so it's a cation from a strong base. So therefore, this ion itself is going to be very weak. Okay, so since it's going to be so weak, it's going to be pH neutral. It's not going to affect the pH. Okay, so this sodium ion is going to be pH neutral. Okay, and then that's for the sodium ion. Okay, now let's look into the other one. Since it's not going to affect anything, so I'm just going to cross out. Okay, cross out. So it's not going to affect our pH. So apparently the fluoride ion is going to give us a story, and let's see what the story is about. Okay, so fluoride ion itself, fluoride ion is the conjugate base of the HF, which we already talked about. This is a weak acid. Okay, as we said. Okay, so if you have the weak acid is quite weak, its conjugate base is gonna be relatively strong. Okay, so therefore this fluoride ion is gonna affect our pH. Okay, then how? And then into acidic solution or basic solution. Again, let's look at it. What is it? It's a conjugate base. It's conjugate base. Okay, so conjugate base. So what do you think this fluoride ion is going to turn the solution into? Yes, it's going to affect our solution into a basic solution. Okay, so that's first of all, you should analyze this. Okay, so then therefore, you know at the end, your pH value is probably gonna bigger than 7. Why? Because we just decided it's a basic solution. Okay, so now let's look into the actual value, what this value is gonna be. Okay, so now again, we already analyzed this solution. We really should just look into the fluoride and see what reaction it is gonna have with water. Okay, so now let's start to write out the equation. Okay, so fluoride, when you have this on with water, what are gonna be the product? Okay, so then you go, how do I know? It's okay, if you don't know, we can analyze it. Since it's a base, what do we say as a definition for a base? Yes, it's gonna accept the proton. From where? From water molecule. Okay, so it's gonna grab a H to himself, so it's gonna be HF, okay, hydrofluoric acid. Okay, and then if you grab the hydrogen from H2O, so what's left? OH. Okay, then again, this sounds about right after you read out the equation, as we already just decided the fluoride is gonna have the solution turn into weakly basic solution. Okay, so then again, if you have OH as the product, okay, that sounds about right. You're gonna have OH, it's gonna be weakly basic. Okay, so now let's keep on going. Okay, since let's go back to what we're trying to find out, the pH. And then pH is about what? pH really is about the concentration of hydronium ion at equilibrium, right? Okay, so this is gonna give us pH. Okay, so then the question will be, what's the hydronium ion concentration? Okay, so then let's see what is. So how are we gonna find out? From this solution, we're gonna find out the OH concentration, and then you already know OH is related to hydronium ion, so then therefore we can go to pH eventually. Okay, so then the question will be, okay, now we can try to solve the OH equilibrium concentration, okay, from this equation. Okay, so then in order to do that, we pretty much, you already know that, right? We have to set up S table. Okay, so that now we're gonna do that. Okay, so the S table, at this by now everybody is very familiar with S table. Okay, so let's just draw this real quick. Okay, so I see initial change in equilibrium. Okay, and then one more time, that water is a pure liquid, so it's not gonna affect. So I'm just gonna leave it out. Okay, so it's not gonna affect our equilibrium. Okay, so we have the concentration of these three. Okay, these three again brackets represents concentration. Okay, so the initial concentration, let's see, what do we know? Okay, so we know the concentration of the salt. Okay, so this is what we know. Then you go, how is related to the initial concentration of fluoride? Let's look at our equation over here. So every 1 mole of sodium fluoride is going to turn into 1 mole of sodium and 1 mole of fluoride. Okay, so it's 1 to 1 to 1 ratio. Okay, therefore the initial concentration of fluoride, okay, so I'm gonna write over here, so NaF will equals to the concentration of fluoride, because again it's 1 to 1 ratio. Okay, so therefore this is gonna equals to 0.22 molarity. Okay, so now we're gonna put that value into our initial. Okay, so this will be the initial concentration of fluoride. Okay, and the other two, it's 0. We don't have anything. Okay, we don't have anything other than the fluoride and sodium ion. Okay, so sodium ion is not gonna affect, so we're not included into our consideration. Okay, so now what's the change? Again, by now you know it inside out. Okay, Q is gonna be equals to 0, smaller than K. Okay, so it's gonna be moving to the forward direction, so therefore it's going to be negative, positive, positive. Okay, so it's negative x, positive x, positive x. Okay, and then over here will be 0.22 minus x, x, and x. Okay, so now we have the equilibrium concentration expressed by this variable x. Okay, and then one more time, what are we trying to look for? We're trying to look for this value, because if we know the OH, then we can go back to hydrogen amount, and then we can go to pH. Okay, so that's what we eventually want. Okay, so then again, we're gonna solve this. Then you go, let me just express the K because that's what we wanted the S table for, right? So let's express the K for my equation over here. Okay, so the Kc for this equation will be, Kc will be HF at equilibrium, the concentration of it, and hydrogen amount at equilibrium, okay, over fluoride ion concentration at equilibrium. Okay, so let's see what's this case K really is. I read a Kc because C just represents concentration, but for this chapter we're talking about acid base, so it's gonna be Ka or Kb. Let's see what it's gonna be. How do you know? Look at your expression. Your expression has OH. What's OH about? Yes, it's a base. So this is gonna be a Kb expression. Okay, so it's a Kb. Okay, so it's a Kb. Okay, then you go, let's see what else we know from this question. What else we know? We know a Ka value for HF. You go, I want to know about fluoride ion. Okay, however, I know a Ka value for HF equals to 3.5 times 10 to the power negative 5. You go, what's the relationship? As we say, okay, as we talk about during the class, the weak acid Ka times its conjugate base Kb will equal to Kw. This is a very, very important relationship. Okay, so the very, very important relationship is Ka times Kb equals to Kw. In our case, this K value is a weak acid and multiply the Kb of its conjugate base. Okay, and then you have the Kw. And then this question I already told you is at 25 degrees Celsius, so that is implied the Kw equals 1.0 times 10 to the power negative 14. Okay, and then we know the K value of hydrofluoric acid. Now we can calculate the Kb. Okay, so Kb of the fluoride ion equals to Kw divided by Ka. Okay, so that's going to be 1.0 times 10 to the negative 14 divided by 3.5 times 10 to the power negative 5. This gives you the value as 2.9 times 10 to the power negative 10. Okay, so that's the Kb value. Now we can use it back into our equation. Okay, so now I'm going to also plug in the equilibrium expressions into our Kb. Okay, so now this Kb equals to x times x over 0.22 minus x equals to 2.9 times 10 to the power of negative 10. Okay, and then again for this value, equilibrium constant is quite small, and then your initial concentration 0.22 is relatively big, so let's try small approximation. Okay, so we're gonna try small approximation. Okay, and then that means we can assume that x is very, very small, so then we say that x equals 0. Okay, so we can eliminate. Okay, so now we will have x squared over 0.22 equals to 2.9 times 10 to the power negative 10. X squared equals to, you're going to cross multiply 0.22 times 2.9 times 10 to the power negative 10, and you're going to take a square root on both sides, then you get x equals to 8.0 times 10 to the power of negative 6. Okay, so you solve this x. Okay, so then let's go back to our x table. Okay, so the x again is solved as 8.0 times 10 to the power negative 6. This is what is OH, the concentration of OH. Okay, and then you go again, I want to calculate pH. Okay, so then we already know what to do. There are two ways to solve for it. Okay, so one way, of course, you can go, this is the most time people like to do this. Okay, so you have OH concentration equal to 8.0 times 10 to the power negative 6. And then this, you can go for POH because that's straightforward. Okay, for POH will be negative log of the concentration of OH. Okay, so then you have negative log of 8.0 times 10 to the power negative 6. This gives me the value around 5.10. Okay, and then we're looking for pH, and then pH equals to 14 minus pOH equals to 14 minus 5.10, give you a 0.90. Okay, so that will be the pH. Of course, you also could go the other way, so that will be, I'll just write the plan out for you. So that will be, you go from OH, you can go to hydronium ion concentration. How do we do this? It will be hydronium ion concentration equals to Kw divided by the OH concentration. Okay, and then from a hydronium ion concentration, you can go to pH. So this will be the pH equals to negative log of the hydronium ion concentration. Okay, so this is how you're going to do this. This is just a different way. Okay, so you can go this way or you can go this way. Give you both the answer. At the end should be 8.10. Okay, and then just one more thing, and then we should have checked before we move on to the calculation, right? After you get this, after you get the x, because of we use a small approximation, we should check if it's valid. How do you check the validation of the small approximation? Yes, use the x value divided by the initial concentration multiplied 100%. Okay, you do this, it's going to be 0.36%, which is smaller than 5%, so small approximation is valid. Okay, so that's good. Okay, otherwise you have to go back all the way over here, then use quadratic equation to finish the calculation. Okay, so this question again. This question is really good question, and make sure you understand the whole process. Okay, so this will be the determine the pH of a salt solution. Okay, so thank you for listening.